Let's look at example 6. Suppose we know that final exam scores in a statistics class are normally distributed with a mean of 63 and a standard deviation of 5. We want to find the probability that a randomly selected student scored more than 65 on an exam. So the first thing we're going to do is draw the picture of what we've been told. Here we know it's normally distributed, so we have a bell-shaped curve that's centered at the mean of 63 and has a standard deviation of 5. We want to find the probability that a randomly selected student scored more than 65 on this exam, so we'll put 65 right here, and more than would be to the right, so we're going to shade that in. Now, we can't just go directly to our table and look up things like 65 because that only works for a standard normal distribution. So we need to find a z-score. And our z-score tells us to take the observed value minus the mean and divide it by the standard deviation. And we find that that value is 0.4. So now we can go to our standard normal distribution, which is centered at 0 with a standard deviation of 1, and look up the area to the right of 0.40. Some of you might be thinking, we can't look up the area to the right directly of 0.40. We need to look up the area to the left of 0.0 and subtract it from 1. If you were thinking that, you're right. So if we go to our standard normal table and look up 0.4 in the 0.00 column, you should find that the value is 0.6554. So that the area above 0.40, the probability that z is greater than 0.40, is actually 1 minus 0.6554, which is 0.3446. These two distributions are proportionate, and because of that, we know that the area to the right of z equals 0.40 is going to be equivalent to the area to the right of 65. So our answer, the probability that a randomly selected student scores more than 65, is 0.3446. And there's your answer.